here. So I don't have to plug in here, and I don't have to plug in here. The sign will be given by that. Why? How come? This is always positive. This is always positive. Don't waste your time to find the sign and plug in there. So I'm going to plug in 0 in between solutions, and I realize it's negative. And when I plug in outside, like 10 or negative 10, it's going to be positive. Okay. At this point, I have to make sure that these two work well together. That's the moment of truth. Okay. From negative infinity to negative 2.6, is the function increasing? Yes, it is. From negative infinity to negative 2.6 is increasing. From negative 2.6 back to negative infinity, yes, it's decreasing. What type of point is negative the square root of 3, comma, negative 2.6? Anyone?
A maximum?
Very good. Relative max indeed. From positive infinity to 0, the function is decreasing, yes. From 0 to negative infinity, the function is decreasing, yes. There is no sign change. This is nothing. It will be an inflection point. Potentially, we have to look. Okay, so from positive infinity to 2.6 is decreasing, yes. From 2.6 to infinity is increasing, yes. What type of point is the square root of 3, comma, 2.6?
Minimum.
Relative minimum, very good. Almost there, but we have a lot of work with the second derivative. It's not a nice function at all. It's this one. But I'm going to distribute at the top. It will be easier to differentiate. So I'm going to say that the first derivative, I'm going to copy it one more time, as x to the fourth minus 3x squared over x squared minus 1 squared. Why? Because it's easier to differentiate. I want it in the factored form. But when I have to continue and find the second derivative, I'm going to use this. And as you know, I'm going to run out of room, so like I always do. So I'm going to copy it here. So I'm going to copy f prime at x to the fourth minus 3x squared over x squared minus 1 squared. And then the second derivative. The top function prime, 4x to the third minus 6x. Everyone agrees with the top function prime, yes or no?
Yes.
Perfect, times x squared minus 1 squared minus, I copy the top. Who would like to give us the bottom, the denominator prime? Anyone?
So it would be 2x.
Squared minus 1 to the...
So the 1.
Yes, times. Times the inner function prime, which is?
So 2
X.
x.
Good. What about the denominator? Which power?
To the first?
Awesome. Remember to clean it up. And there is a common factor at the top that I wanted out of there immediately. Which one am I talking about?
X squared minus 1.
Of course, thank you very much. So this is out, just one of them. So I have 4x to the third minus 6x multiplied by one of them that is still there. This is out. So I have 2x times 2, which is 4x, multiplied by this. There is no end to this problem. And I chose it, so I can't complain. 1, 3. At least something goes away from this mess. X squared times this, 4x to the 5th. X squared times this, minus 6x cubed. Negative 1 times this, minus 4x cubed, and plus 6x. Minus 4x to the 5th, but plus 12x cubed. Oh, something goes away. Gee. Okay, this is negative 10 plus 12, so that's 2. Wow. And plus 6x. It cleans up quite nicely. But still a lot of work. What do you think I'm going to do next? For sure.
Factor out 2x.
Brilliant. Very good. Clean it up, what I like to say. Good. What is left in parentheses?
X squared plus 3.
Good. Which can never be 0, and this is always a positive number. So when I set the second derivative equal to 0, what is the only solution?
Zero.
Very good. So now, careful though, for the purpose of the sign, yes, I'm on page 8. For the purpose, only for the purpose of the sign, I will rewrite the second derivative like this. 2x, some positive quantity that I don't care about, another positive quantity that I don't care about, and an x squared minus 1. This one, of course, is x squared minus 1 squared. So this is where I have to, now without the 2, of course. This is where I have to plug in x and x squared minus 1. So in that quantity, so this is 0 here. So I need to plug in negative 10. Negative 10, this is positive. But negative 10 will give us a negative number. Now I have to plug in negative 0.5 right here. Negative 0.5. This is negative, and negative 0.5, this is also negative. So it will be positive here. With 0.5, this will be negative. And with 10 again will be positive. So then, does not hold water, holds water, does not hold water, and holds water. Ah, a lot of work, as you've noticed, but it's done. I lied. One last thing that we need to do before we graph it. We need to find the slant asymptote of x to the 3rd over x squared minus 1. And this is something from your past. We need to use the long division. Long division. X squared times what is x cubed is x. Go back and distribute and change the sign. X times x squared is x cubed, change the sign. X times negative 1 is negative x, change the sign. And that's it, because I cannot continue. So then the function that was initially x cubed over x squared minus 1 can be simplified or written as x plus x over x squared minus 1. X is the quotient, x is the remainder. This is the quotient, and this is the remainder. And this is the divisor. Only this is the slant asymptote. Only the quotient. So in order to finalize this problem, 5 pages ago, okay, The only thing I need to add to my table so I don't forget, y equals x slant asymptote. Just a quotient. Okay. So now I'm ready to graph. I don't care for anything but my table. Nothing else matters. So I start with the asymptotes, always. They're not part of the graph, but they have to be graphed. One of them is the vertical asymptote at -1. The other one is the vertical asymptote at 1. And the other one is the slant asymptote y equals x. And we know how to graph this from a long time ago. Is y equals x. Next, I need to plot negative the square root of 3, which is roughly -2. Am I running out of time? No, I have 2 more minutes. So negative the square root of 3, -1. 0, 0. The square root of 3 and +1. Okay. The function opens downward. Okay, sorry. It must be higher because it opens downward. It makes no sense. Okay. I realize that something is terribly wrong. How can it open up and get there? So the function is opening down coming from -infinity to the point of maximum. And then it continues to, this time, this was increasing. Now it decreases, opening downward towards -infinity. That part is done. Next, it's coming from +infinity, opening up, decreasing to 0. It changes concavity. This is an IP. I forgot to ask you because it changes sign. This point does not exist. This point does not exist, even if the function this derivative changes sign. But here the function exists and the derivative changes sign. Opening downward towards -infinity. On the other side, it's coming from +infinity. It comes to a minimum, relative minimum, and then it approaches infinity, going closer and closer to the slant asymptote. So this is the function x to the third over x squared minus 1. I know I only have 3 seconds probably, but allow me just to share my screen for a second to show you how you check this. We don't need to check anything. If you have to go, you can go. So the function was x to the third. Careful how you enter it, and divide by, in parentheses, x squared minus 1. Don't forget parentheses. But if you do not ask the calculator to graph another function, which is the slant asymptote, it will not graph it for you. And now zoom 6. I will use the standard. And here it is. So it does not graph, for some reason the software does not graph the vertical asymptotes, or I don't know how to add them in. But obviously the vertical asymptote is -1 and +1. Here's the graph in blue, and here's the slant asymptote. Thank you.